Hi students, I am Dr. B. Ravi Kumar, Associate Professor, Department of ECE, Institute of Aeronautical Engineering. So I'm gonna discuss the definitions and terminologies from Module 5, Sequential Circuits and Fundamentals. So the some definitions from these sequential circuits helpful to understand that. So the flip-flops and conversion between flip-flops, and then shift registers, counters, sequential counter like synchronous sequence circuit and asynchronous sequential circuits. Let us see some basic definitions of this module 5, which is nothing but sequential circuits and fundamentals. So first of all, what is counter? Basically, counter is a sequential circuit. Before going to that, I would like to say that define the sequential circuit. Sequential circuit is a digital circuit which having a combinational circuit with a feedback memory element. Then that is called sequence circuit, and also we can define as sequential circuit is the output of that circuit is not only depends upon the present input and also previous present input and also previous output. Then that circuit is called sequential circuit. I'll repeat it once again. The sequential circuit is a circuit in which the output of the sequential circuit is depends upon present input and also previous input. Then that circuit previous output, that circuit is called a sequential circuit. And then what is a counter? Counter is basically a sequential circuit, counts those pulses which are driven by a clock, or counts the sequence circuit which can counts the binary values based on the number of flip-flops. If it is 3-bit 3 flip-flop counter, which can maximum of counting 8 numbers. What are the categories of counters? Also asynchronous and synchronous counters, single and multi-mode counters, and modulus counter. What is multi-mode counter? And if the same counter circuit can be operated in both up and down, up counter, down counter, then that is called multi-mode counters. And what is asynchronous counters? Basically, for synchronous counter, we must use the common clock, global clock for all the flip-flops. Whereas in the asynchronous counters, each flip-flop is triggered by previous flip-flop. Then that counter is called asynchronous counter. So basically, we applied the clock for first flip-flop, then the output of that flip-flop is driven by the next following flip-flop. Then this type of counters or this type of sequential circuits are called asynchronous sequential circuits. What is ripple counter? Basically, the ripple counter is an asynchronous counter where only the first flip-flop is clocked by an external clock. And then where the ripple counter is used, I'll explain. Basically, these counters are used for counting the numbers or counting the clock pulses. It can also be used for frequency divider, time measurement, frequency measurement, and distance measurement, and also for generating square waveforms. Based on the clock pulses, the counting of a given number, then the clock pulse upgraded. So clock pulse updated means you will get generating the clock pulse. What is the difference between ripple counter and synchronous counter? In synchronous counter, however, the external event is used to produce a pulse that is synchronized with the internal clock. Johnson counter. Johnson counter is modified with a ring counter where the inverted output from the last flip-flop is connected to the input to the first registered, first flip-flop. That counter is called Johnson counter. If I'm taking 4 counters, the output of the first flip-flop is connected to the input of the next one. For the last flip-flop, Q bar is connected to the input of the first one. Then that is called Johnson counter. If it is connected with the direct last flip-flop connected with the output of Q is connected with the input of this one, that is called ring counter. It's like a ring. If you see that shape of that one. The purpose of shift register. Basically, shift register is a group of flip-flops connected together to store the data, and also if you apply the clock pulse, based on the clock pulse, that the data which is in the shift register is shifted to right or left based on the application of the shift register. So there are basically serial to serial shifting or serial to parallel shifting or parallel to serial and parallel to parallel shift registers are available. And what is the difference between flip-flop and latch? So for the latch is a basic element in the sequential circuit. So in which based on the activity of input changes, then the output will change. Whereas in flip-flop, the output of the sequence circuit has been changed. It will be changed by the application of the clock. A flip-flop is a circuit that has 2 stable states, can be used to store binary information. And also the circuit can be made to change state by signals applied to one or more control inputs. What is the excitation table? We know that truth table. The truth table having the possible combination of input column and its corresponding output with respect to circuit. For example, if you take the truth table for combination circuit, truth table for sequential circuit. So in that there is a binary information for input and outputs. Whereas in an excitation table shows that minimum input that are necessary to generate a particular next state. When the current state is known, they are similar to truth table, but truth table and state table. But the thing is that we have to give that the possibilities of inputs changes corresponding with them, so that corresponding next state will be changed. But what are the combinations of input that the next state will be changes? That information is given in an excitation table. Applications of flip-flop, basically data storage, data transfer, and registers, shift registers, counters, frequency division, memory. So these are all the applications of the flip-flops. So we can see all these definitions from the sequential circuits. So basically, understanding of this sequential circuit, must know the difference between combinational and sequential, and what is flip-flop basic element of flip-flop, and combining of flip-flop nothing but register, memory, register, and then with the help of that combining of flip-flops in a proper way, and we will counting the given numbers in a pattern. So based on that, we can divide into synchronous sequential counters and asynchronous counters. So most of the times in a real-time practical application, circuits are having states. Okay, so with the help of Mealy and Murray machines, state machines, we can design the sequential and sequential circuits. So with the help of simple definitions and terminology in the sequential circuits, we will come to know that how to design the sequential circuits. So this is all about definitions from the sequential circuit. Thank you. These are the references. These references will helpful to understand that the sequential circuit definitions. First one is the lecture notes from the IARE website. And second one is Digital Design by Maris Mano, fourth edition. Both of them will helpful to understand the definitions and the topics which are related to digital electronics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.